This video is to continue my brief review of the statistical models I learned from MIT course Data and Analysis for Social Scientists. The KS test reports a maximum difference between the two cumulative distribution and calculates a p-value from that and the sample size. Kernel regression is a non-parametric technique in statistics to estimate the conditional expectation of a random variable. The objective is to find a nonlinear relation between a pair of random variables x and y. The cross-validation is a method to estimate the prediction error of our regression estimator. So we split the data into two parts, training data and validation set. We then use the data in the training set to construct our estimator and predict the value of response on the validation set, and then calculate the quality of our prediction. Notice here, each time we leave one observation out as the validation set, and we use the remaining data points to fit the data and then predict the data that we left out. Simple linear regression is used for finding relationship between two continuous variables. One is a predictor or independent variable, and the other is response or dependent variable. It looks for statistical relationship, but not a deterministic relationship. So sometimes those assumptions are violated, then we have to construct a different kind of linear regression model for it. Dummy variables could be used when you estimate the difference between the treatment and the control group for randomized control trials using this kind of regression framework. The Neyman standard error adjusts for sample size for each group, but the OLS standard error only adjusts for the overall sample size. But if your sample size are big enough or similar in treatment and the control group, this doesn't matter. Difference in difference calculates the effect of a treatment on an outcome by comparing the average change over time in the outcome variable for the treatment group compared to the average change over time for the control group. The underlying assumption of difference in difference design is that the trend of the control group provides an adequate proxy for the trend that would have been observed in the treatment group in the absence of treatment. Thus, the difference in change of slope would be the actual treatment effect. The assumption here is that the treatment group and a control group must follow the same trend in the pre-period. In regression analysis, when a residual plot reveals a dataset to be nonlinear, we could apply nonlinear transformation to the independent or dependent variables. If this transformation increases the linearity of the relationship between variables, it allows us to use linear regression techniques approximately with nonlinear data. There are many ways we can do it, such as polynomial expansion, take a log, interact X, locally linear regression, or use machine learning. I want to talk more about the locally linear regression. Around each point where we are interested in evaluating the function, we run a weighted regression of yi on xi, where the weights will be given by kernel. For the set of observations within the bandwidth, we take the predicted value from the regression as best predictor for yi. So it's exactly like a kernel regression, but we use our linear regression in each little interval. The two most common approaches to estimation using a regression discontinuity design are non-parametric and parametric. The omitted variable bias exists if the omitted variable is a determinant of the dependent variable and is correlated with an independent variable specified in the regression. In an economic model, an exogenous variable is one whose value is determined outside the model, while endogenous variable is determined by the model. The procedure for correcting this endogenous problem involves finding instruments that are correlated with the endogenous regressor but uncorrelated with the error term. Experimental design refers to how participants are allocated to the different groups in an experiment. There are more materials in this area. I just listed mechanisms which introduce randomization. So if you are interested in those materials, please check out this course on EDX.